So in the previous class, we have seen about the step signal and ramp signal. We have seen that step signal introduces a jump or discontinuity, whereas ramp signal introduces a slope. Okay, that's what we have seen. Suppose if it is given like this, r of t plus 3, r of t plus 3. So it is a ramp function which is going to introduce a slope at minus 3. So how it look like? Up to minus 3, the slope value 0. After that, slope is equal to 1. Now, can anybody tell me at 0 what is the amplitude? Slope 1 means, I already told you, 1 unit change in x-axis leads to 1 unit change in y-axis. In the similar manner, there is a 3 units increase, so there must be 3 units increase, so it has to be 3. That's what the meaning of it. Okay. Next, suppose if I say, can you draw this function r of t minus r of t minus 2. So here we are having two corner points. One is nothing but 0, another one is nothing but 2. So how we can draw this function? First, we have to represent the corner points where they are present. 0, 2. So let's see. Up to 0, the slope is 0. After that, it is introducing a slope of 1. This is a slope 1 line. So it is going to continue up to 2. So up to 2, a slope 1 line continuing. So that, can you tell me what is the amplitude at 2? Because slope 1 line, 2 unit change in x-axis, it's 2 unit change in y-axis. Next, at 2, it is introducing a minus 1 slope. Already 1 is the slope is there. If it is introducing minus 1 slope, then the final slope will become 0. Then slope 0 line means it's a horizontal line. Slope is 0. If you got any doubt, let's see. I told you the coefficient indicates change in slope. At 2, what is the coefficient actually? Minus 1. Whether I am getting minus 1 or not. After this, slope is 0. Before this, slope is 1. Final slope, initial slope. 0 minus 1 minus 1. That's what the meaning of change in slope. Okay. Next. R of t minus 2 r of t minus 2. How we can draw this? Again, 0 is the corner point, 2 is the corner point. Up to 0, slope is 0. After that, slope 1. Slope 1 means it will go to 2. This is already you know. But at 2, how much is the slope introduced? Actually minus 2. Already slope is 1. If I am introducing minus 2 slope, then final slope will become minus 1. So whenever you see a negative slope, that has to be decreasing line. So it has to be like this. Slope is equal to minus 1. So where it meets the x-axis, 2 units has to decrease. Then there must be 2 units has to be increased. So 4 is the line. So it will go like that. Next, suppose r of t minus 2 r of t minus 2 plus r of t minus 4. If I try to draw this, how it is going to look like? 0, 2, 4. Up to 0, slope is 0. At 0, slope introduced is 1, 2. Next, at 2, the slope introduced is minus 2. So it is going to be minus 1. Up to 4 it will go. S is equal to minus 1. At 4, again slope introduced is 1. So already minus 1 is there. If I introduce plus 1, then finally slope will become 0. This is what the meaning of it. Okay, take it. So here also we can say, what is the final slope? 1 minus 1, that is 0. What is the final slope? 1 minus 2 minus 1. What is the final slope? 0. 1 minus 2 plus 1. So the coefficients of the ramp functions is going to give you the final slope, but not the final amplitude. Remember that. So observation, final slope is equal to sum of the coefficients. Sum of the coefficients. Okay, take it. Let's see one more example. Let's see, suppose if the waveform is given, how to write the function. Let's say I have to find out x of t. For that, what we have to do? So observe here, do we have any steps here? No. Answer is no. We don't have any steps. We don't have any jumps here. But we are having corner points. What are they? 0, 1, 2. These are the corner points. Why we are calling them as a corner points? Because at those points we got the slope change. Wherever there is a slope change, those points are called as corner points. That is as simple as that. So here, let's see. We can get a ramp function r of t, but we don't know what is the coefficient. To understand the coefficient, first we have to see how much is the slope before and after the point. What is the slope of this line? 0. What is the slope of this line? 1, because 1 unit, 1 unit. What is the slope of this line? -1. What is the slope of this line? 0. So that is what the meaning of it. Okay. Now let's see. At 0, how much is the slope change? 1 minus 0. So x of t can be written as r of t. At 1, how much is the slope change? -1 minus 1. -2 r of t minus 1. Next, at 2, 0 minus of -1, that is plus r of t minus 2. So that's what the function we have to write. Okay, take it. Represent the slope of each line and find the what is the change in slope. That means final slope minus initial slope. Okay. We already know I can write r of t as t into u of t. This is already we have seen t into u of t we can write. If I say r of t minus t naught, can you write in terms of t u of t? Yes. Wherever t is there, that is replaced with t minus t naught. That's what we have to do now. T minus t naught into u of t minus t naught. That is as simple as that. Okay, this is the one thing you have to remember. Next, we know differentiation of r of t, which is u of t. In the similar manner, differentiation of r of t minus t naught, that is u of t minus t naught. Okay. Next, differentiation of u of t, delta t, we know this. In the similar manner, differentiation of u of t minus t naught by dt, that is delta t minus t naught. In the similar manner, we can rewrite this one as t u of t minus 2 t minus 1 u of t minus 1 plus t minus 2 u of t minus 2. This is the way we can write also. Okay, just take this. Okay, let's take this as an example. Find expression for x of t and draw dx of t by dt. Find the expression for x of t and draw dx of t by dt. This is the thing what we have to do now. Okay. So the waveform is involving only corner points. It does not have any jump. Means there is no discontinuity points. Sudden changes are not there. So I can say we can write this x of t in entirely in the form of r of t. Means ramp functions. Okay. To write that, I told you first we have to find the change in slope at each and every point. Okay. Listen. So before this, slope is 0. What is the slope of this line? 1 unit, 5 units. So 5 by 1, slope is 5. Next, slope of this line 0 because it is a horizontal line. Next, decreasing line. Slope is equal to minus 5 because 1 unit, 5 units. So minus 5 units. Next, here slope is 0. So if I want to write the expression for x of t, how we can do that? X of t is equal to, at minus 1, how much is the slope change? 5 minus 0. So 5 r of t plus 1. At 0, how much is the slope change? 0 minus 5. Minus 5 r of t. At 4, how much is the slope change? Minus 5 minus 0. Minus 5 r of t minus 4. At 5, how much is the slope change? 0 minus of minus 5. That is plus 5 r of t minus 5. So this is what the x of t signal expression. Then can you find dx of t by dt? So just now we told you r of t plus 1, that is u of t plus 1 minus 5 u of t minus 5 u of t minus 4 plus 5 u of t minus 1. If I draw this expression in the waveform, how it look like? Minus 1, 0, 4, 5. Okay, this is dx of t by dt. The waveform for dx of t by dt. 5 u of t plus 1. That means there is a jump of 5 units. Continue up to 0. At 0, minus 5. That means drop to 0. Continue up to 4. At 4, again minus 5. That means again drop to minus 5. Go up to 5. At 5 plus 5. So it will again go back to 0. So that's what the final thing it is going to be. It looks like. Actually, to draw differentiation of a curve, we don't have to see this expression. Directly from x of t, we can draw dx of t by dt. How, sir? Listen carefully. In general, differentiation of a curve indicates the slope of the curve. As simple as that. So that is going to indicate the slope of the curve. If you observe carefully, up to minus 1 slope is 0. That's why 0. Minus 1 to 0 slope is equal to 5, which is a constant value. So we are showing like a constant value 5. After that, slope is equal to 0. After that, it is minus 5. Next, again 0. So simply we have to write the slope values. So that is going to indicate dx of t by dt. Okay, take it. Again the same question. Find x of t expression and draw dx of t by dt. To find the expression for x of t, we have to find the slope of each line. We don't have any step function here. Slope is 0. What is the slope of this line? 2 units x-axis, 7 units y-axis, 7 by 2, that is slope is 3.5. Horizontal line slope is 0. So directly we can write x of t is equal to 3.5 r of t minus 3.5 r of t minus 2. If I try to find out dx of t by dt, it will give you 3.5 u of t minus 3.5 u of t minus 2. If I draw this function, dx of t by dt, then what we can get? So simply I told you we have to write the slope values. 0 slope up to 2, the slope is 3.5. 0. That's what the dx of t by dt. Okay, take it. Okay, so this is x of t is given. We have to calculate x of t expression and draw dx of t by dt. So here we don't have any corner points because there is no slope change. Everywhere slope is 0, 0, 0, 0. So there is no slope change. So we are having only jump values. So at 0 there is a jump 0 to 3. Jump is equal to 3. At 2 there is a downward jump. How much is the jump? 3 to minus 1. That is minus 4 is the jump. At 5 there is a jump of 1 unit. Okay, so that's what the jump values. So we can write directly x of t in terms of shifted step function. 3 u of t minus 4 u of t minus 2 plus u of t minus 5. That's what it is. Then to draw dx of t by dt, we are going to get 3 delta t minus 4 delta t minus 2 plus delta t minus 5. If I draw this function, zero, 2, 5. At 0 there is an impulse function of strength 3. That means we have to show it like this. This is dx of t by dt I am drawing. Next, at 2 we are having a minus 4. That means in the downward direction strength is equal to minus 4. That is the impulse function. At 5 we are having a impulse function with strength 1. So this is what the dx of t by dt. Here also we don't have to see the expression for dx of t by dt to draw differentiation. Just remember, whenever there is a discontinuity in a waveform, while you are doing the differentiation, at the point of discontinuities you are going to get an impulse function. So I am repeating again, while differentiating a curve having discontinuities results in impulse functions at the point of discontinuities. That's what the meaning of it. Next, sir, we came to know that wherever there is a discontinuity we are going to get an impulse function. Okay, no problem. Is it in the upward direction or in the downward direction? That is given by jump direction. That means if jump is in the upward direction, upward, Jump is in the downward direction, impulse is in the downward direction. Next, to find the strength is nothing but the amount of jump. That means 3, 3, minus 4, 1, 1, like that. So I am writing those points. Observation. While differentiating a curve with discontinuities, what we are going to get first? An impulse at discontinuity. An impulse at discontinuity. Next, direction of impulse is same as jump direction That is the second point you have to remember. Next, third point, strength of the impulse is equal to amount of jump These are the 3 points you have to remember whenever you are differentiating a curve with a point of discontinuity. So wherever there is a discontinuity, an impulse at discontinuity, direction of impulse is same as jump, and the strength of the impulse is nothing but amount of jump. Okay, take it. Let's see this curve. I want to find out x of t expression and differentiation of the curve. Here also we have to observe the points and what are those points. See here, what is 0? So at this point we are having only slope change. How much? Up to this point slope is 0. After this slope is 2 by 1. Okay. At 1 we are having slope change. Here is the slope 2, here is the slope 0. So it is also corner point. But if you observe carefully, at 1 there is something else is happening. What is that? There is a sudden jump from 2 to 0. That means it is having jump also of 2 units, minus 2 units. Minus 2. That means 0 is the corner point, 1 is the corner point. But 1 is also a point of discontinuity. So wherever there is a discontinuity point, we have to write it a step function. So how we can write x of t now? X of t is equal to, at 0 we have to write only ramp function. How much is the slope change? 2 r of t. At 0 we are having another ramp function. At 1, how much? At 1 slope change 0 minus 2 minus 2 r of t minus 1. At 1 we are having a jump also, minus 2 u of t minus 1. So this is what the x of t. Then what is dx of t by dt? That is 2 u of t minus 2 u of t minus 1 minus 2 delta t minus 1. So if I draw this function, how it look like? Dx of t by dt, 0, 1. From 0 to 1 the slope is 2. After that slope is 0. But at 1 we are having a jump in the downward direction, so that is going to create a impulse function in the downward direction with the strength is equal to -2. That's what the function it is going to be, dx of t by dt. Okay, take it. So I hope you understood if the function is having both slope change as well as discontinuity. Okay. Find the expression for it. Find the expression for the function. This is question number 10. Try this one. Okay. See here one by one. At 0, what is happening? Do we have any slope change before this 0? After this 0, no slope change. But there is a jump here of how much? 1 unit. At t, we are having a jump as well as slope change. This is another line, this is another line. So this is having one slope, this is having another slope. So definitely t is both corner point as well as point of discontinuity. So how much jump we are having? -1. What is the slope here? 0. What is the slope of this line? Change in x-axis, t units. Change in y-axis, 1 unit. So slope is equal to 1 by t. Here slope is equal to 0. Okay. So now let's see how we can write x of t. They said simply asking about the expression for x of t. X of t is equal to, there is a jump of 1 unit, u of t minus u of t minus capital T. At t there is a slope change also, 1 by t minus 0 plus 1 by t r of t minus capital T. At 2t we don't have any jump, only corner point, so minus 1 by t r of t minus 2t. That's what we are getting. So they haven't given this kind of answer. They said u of t minus u of t minus t plus 1 by t. What is r of t minus t? This can be written as t minus capital T into u of t minus capital T minus 1 by t, t minus 2t into u of t minus 2t. U of t minus t, u of t minus t you can take common out, u of t plus 1 by t, t minus 2t, u of t minus t. Try this one. So do it by yourself so that you can get it. Minus 1 by t, t minus 2t, u of t minus 2t. This is what they have given the final answer. Okay, take it. U of n minus u of n minus 4. If I try to draw this function, let's see how it is going to look like. Let's say do the graphical procedure first. U of n, how it look like? This is u of n sequence, how it look like. If I draw u of n minus 4, so that means we have to shift it. From 4 onwards it will start. And remaining values at 3, at 2, at 1, at 0, these values are 0. So if I subtract u of n minus 4 from u of n, then what the result we are going to get? 1 minus 0, 1 minus 0, 1 minus 0, 1 minus 0. But at 4, 1 minus 1, from 4 onwards it will become 0. So this will look like this. 0, 1, 2, 3. U of n minus u of n minus 4. So I hope you understood what I am trying to say here. U of t minus u of t minus 4 is existing between 0 to 4. Whereas u of n minus u of n minus 4, it is existing only between 0 to 3. From 4 onwards its value is 0. So it is not existing at 4. Okay, keep that in mind. Okay, make a note. X of n is equal to 1 minus summation k is equal to 3 to infinity delta n minus 1 minus k. If x of n is equal to u of capital Mn minus small n naught, then find m and n naught values. Okay. How we can solve this? Remember, in a signals and system topic, whenever it is difficult to analyze mathematically, then it is going to be very simple by using graphical. Means graphical procedure may be very easy in this question. Okay, let's check it out how easy it is going to be. Okay, so let's see. Let's treat this whole function x of n as a combination of two functions. One is this summation function, another one is 1. So this function has to be subtracted from 1. That's what we have to do. So let's see, first we will take a function which is called as 1. So let's say some function which is 1. Okay, 1 means at each and every instant of time. That means 0, 1, 2, so for each and every instant, all values of n, its value is equal to 1, 1, 1, 1, like that. That's what the meaning of 1. Okay. Next, can you tell me what is delta n minus 1 minus k when k is ranging from 3 to infinity? Summation k is equal to 3 to infinity delta n minus 1 minus k. K value, suppose if it is 3, then it is delta n minus 1 minus 3 n minus 4 plus delta n minus 5 plus delta n minus 6 and so on like that. So if I draw this function, so delta n minus 4, that means it is starting at 4, 5, 6 and so on like that. So if I subtract them, 1 minus of this, what is this result? So from 4 onwards it is 0, so it is existing only up to 3, 3, 2, 1, 0, -1 and so on like that. This is what the function finally what we are going to get. Have you remembered this? Suppose let's say in continuous time case we have seen that u of let's say minus t plus 3, how it look like? It is how it look like. Have you remembered this? Suppose u of minus t minus 2, this is existing up to -2. We have seen these things in the continuous time case. Exactly the similar way, so this is also can be written as u of minus n minus 3. U of plus 3, because it is up to plus 3. So this is what we are going to get. So already given x of n, which is equal to u of capital M n naught minus mn minus small n naught, which is nothing but u of minus n plus 3. So from this, what is the capital M value? Minus n. What is the n naught value? Minus 3. This is the final answer we are going to get. Okay, take it.